sampling techniques and misuses of statistics. The study of statistics was originally used by governments to make large amounts of numerical information, but the use of statistics today has grown significantly, and it's applied in basically all walks of life, from estimating the unemployment rate, the cost of living, providing the results of different polls. Statistics is used in many professions. In fact, it's probably difficult to find a profession that does not depend on statistics or use statistics in some way. But before we get too deep into our lesson, let's start with a few definitions. So the first definition, and I've put them in blue font and italicized each word that we're defining. So statistics for us is the art and science of gathering, analyzing, and making inferences or predictions from numerical information obtained in an experiment. The numerical information so obtained is referred to as data. Statistics is divided into two main branches: descriptive and inferential. This word for a second was the word in, and that was a mistake, a typo. So it's descriptive and inferential. Descriptive statistics is concerned with the collection, organization, and analysis of data, whereas inferential statistics is concerned with making generalizations or predictions from the data collected. A population consists of all items or people of interest. The statistician often uses a subset of the population called a sample to make predictions concerning the population. It's important that we understand the difference between a population and a sample. A population includes all the items of interest, but a sample just includes some, right? Some of the items in the population. Now, statisticians use samples instead of the entire population for two reasons. Sometimes it's just impossible to obtain data on an entire population, so sometimes it's just plain impossible. Another reason why a statistician would use a sample instead of the entire population is it's less expensive, because collecting the data takes less time and effort when you're just using a sample. For example, suppose that you wanted to determine the number of each species of all the fish in a lake. Well, to do so would be almost impossible without using a sample. If you did try to obtain this information from the entire population, the cost would be astronomical, right? Or maybe you wanted to test soup cans for spoilage. If every can produced by the company was opened and tested, the company wouldn't have any product left to sell. So instead of testing the entire population of soup cans, maybe just a sample is selected. The results obtained from the sample of soup cans selected are used to make conclusion about the entire population of soup cans. Consider the task of determining the political strength of a certain candidate running in a national election. It's not possible for pollsters to ask each of the approximately, how many eligible voters do we have in the country? Like 250 million or so. So pollsters, they select and use a sample of the population to obtain their information. How large of a sample do you think they use to make predictions about an upcoming national election? You might be surprised to learn that pollsters use only about 1,600 registered voters in their national sample. So how can a pollster using such a small percentage of the population make an accurate prediction? So that leads us to an unbiased sample. An unbiased sample is one that is a small replica of the entire population with regard to income, education, gender, race, religion, political affiliation, age, and so on. Now, there are different techniques, sampling techniques, and so we're going to go through a few of them together. We're going to start with random sampling. If a sample is drawn in such a way that each time an item is selected, each item in the population has an equal chance of being drawn, then the sample is said to be a random sample. A systematic sample is obtained by selecting a random starting point and then selecting every nth item in a population. For example, in a factory producing bicycles using an assembly line, a systematic sample could be obtained by randomly selecting a bicycle and then selecting every 20th bicycle thereafter coming off the assembly line. Let's go to cluster sampling. A cluster sample is sometimes referred to as an area sample because it is frequently applied on a geographical basis. So to select a cluster sample, you basically divide a geographic area into sections, and then you randomly select the sections or clusters. When a population is divided into parts called strata for the purpose of drawing a sample, the procedure is known as stratified sampling. Now, stratified sampling involves dividing the population by characteristics called stratifying factors like gender or race or religion or income. So these are called the stratifying factors that help kind of, divide the population. And the last technique for sampling is a convenience sample, which is basically a sampling technique that uses data that are easily or readily obtained. Okay? All right, here we go. Example 1. Identify the sampling technique used to obtain a sample in the following scenarios. Explain your answer. So the first one, every 20th smartwatch coming off an assembly line is checked, is checked for defects. What kind of sampling technique do you think this represents? This first one is systematic sampling. And it is this type of sampling because the sample is obtained by drawing every nth item. In this case, it's every 20th smartwatch, right? So this is definitely systematic sampling. Let's go to the next one. A $50 gift certificate is given away at the National Nurses Convention. Tickets are placed in a bin and the tickets are mixed up. Then the winning ticket is selected by a blindfolded person. So which one do you think this one is? The answer is random sampling because every ticket has an equal chance of being selected. I hope you got that one right. Let's go to the next one. Children in a large city are classified based on the neighborhood school they attend. A random sample of 5 schools are selected. All the children from each selected school are included in the sample. For this one, I'm going to say it's cluster sampling because they are dividing the population into geographic areas. And that's how the sample is selected. Yeah, definitely cluster sampling. All right, next. The first 50 people entering a zoo are asked if they support an increase in taxes to support a zoo expansion. Okay, this one is definitely convenience sampling because the sample is selected by just picking data that's easily obtained. I mean, you want to collect data about the zoo, so of course just get the people that are just exiting the zoo or entering a zoo, right? But here, a word about convenience sampling, if I may. We have to be careful, even though a convenience sample may be very easy to select. We have to be cautious when we're using a convenience sampling because the results obtained by this method could definitely be biased. Like in this example, the results are going to be very much biased. I mean, these people are entering a zoo, so they're already fans of the zoo. They already like going to the zoo, or else they wouldn't be there. So it's likely that these people that are being asked if they support an increase in taxes to support a zoo expansion, it's likely that they're going to say yes, I support that, because they're at the zoo. They like the zoo. They are supporters of the zoo. So this sampling technique, although it's relatively easy to obtain, it could be very much biased. So we just have to be careful when we're using a convenience sampling. Okay, last one. All registered vehicles in the state of California are classified according to type: subcompact, compact, midsize, full size, SUV, and truck. And then a random sample of vehicles from each category is selected. This is definitely stratified sampling. The vehicles are divided into strata based on their classification, right? And so, these are the stratifying factors. So yeah, definitely stratified sampling. I hope you agree with those results. We end our lesson talking about the misuses of statistics. It's so important that when we use statistics, that we're using them properly, and we are interpreting them correctly. And so before we accept any statistics as fact, we should examine statistical statements very carefully. Here are two questions that you can ask yourself. Number one, was the sample used to gather the statistical data unbiased and of sufficient size? Question two, is the statistical statement ambiguous? Meaning, can it be interpreted in more than one way? Here's an example of how we should be cautious. Look at this advertisement. 4 out of 5 dentists recommend sugarless gum for their patients who chew gum. Okay, in this advertisement, we don't know the sample size and the number of times the experiment was performed to obtain this statement, to obtain these results. So the sample size could have been super small, or it could have been really, really large. A second thing that I would like to say about this advertisement is it does not mention that possibly only 1 out of 100 dentists recommend gum at all, right? So the advertisement doesn't even mention that. It mentions that 4 out of 5 recommend sugarless gum, but it could be very true that only 1 out of 100, right, recommend gum at all. Maybe most dentists don't even recommend gum at all. In another advertisement for golf balls, a driver golf ball is hit and another brand golf ball is hit in the same manner. We are told that the driver golf ball travels farther, and we're supposed to conclude that the driver golf ball is the better option. But what the advertisement does not mention is the number of times the experiment was previously performed, or the results of the earlier experiments, So there could be bias included in this, like wind speed and direction, or the fact that no two swings are identical, or that the ball may land on a rough or smooth surface. We're not told any of these things in this advertisement. Another problem is when we use vague or ambiguous words, because that could lead to statistical misuses or misinterpretations. Like, for example, the word for average is a huge culprit for this. There are many different averages used in the study of statistics. And later on, in a later lesson, we're going to discuss 4 of these averages, 4 different kinds of averages. And the thing is, each is calculated differently, and each may have a different value for the same sample. Like, for example, during contract negotiations, it is not uncommon for an employer to state publicly that the average salary of its employees is $45,000, whereas the employees' union states that the average salary is $40,000. So who's lying? In this case, actually, both sides are telling the truth. It's just that each side will use the average that best suits their needs to present their case. Advertisers also use the average that most enhances their products. And consumers often misinterpret this average as the one with which they are most familiar. So, more about that in another lesson. Another word like average that is ambiguous is largest. For example, let's say Macy's claims that it is the largest department store in the US. Now, does that mean largest profit, largest sales, largest building, largest staff, largest acreage, largest number of outlets? Who knows, right? So that's very ambiguous. Another deceptive technique is when they state a claim from which the public may draw irrelevant conclusions. Like, for example, let's say a company claims that its paper towels are heavier than its competition's towels, and therefore they will hold more water. But think about it. Is weight a measure of absorbency? A rock is heavier than a sponge, yet a sponge is more absorbent. Also, graphs could be very misleading in statistics. Like, and there's many examples, but here's one. This is a circle graph, and it's a circle graph that is giving the top 6 reasons why Americans say they use the internet. So 37% say they use the internet for email, 42% say they use the internet to gather information about products, 49% say they use the internet for research, 15% of Americans use the internet for news, 16% say they just surf the internet for news sites, and 24% say they use the internet to purchase goods. Now, in a circle graph, the total circle represents a whole, represents 100%. So the sum of the parts, if you add up all the parts, you should get 100%. But this graph is misleading because if you add up all of these parts, what's 37 plus 42, 49, 15 plus 16, and 24? That adds up to 183%, which is way over 100%. So in this case, they should have used a different type of graph, not a circle graph, to display the top 6 reasons why Americans use the internet.